All right, so this is the last section of the book that we're going to cover. Last section of chapter 12 as well. So this is on the binomial theorem. And at least the basics of this you definitely have seen in algebra because a lot of this and the basis of this is just foiling out perfect squares or perfect cubes, and then we can get them to higher exponents. So if we want to talk about expanding a plus b, so this is a binomial, two terms, raised to some exponent, some integer exponent. You've done this before. You've seen in algebra, you would have done something like x plus 2 squared or x minus 3 squared, something like that. And so we're just going to kind of expand that into higher exponents, and we're also going to come up with easier ways to do it besides, for instance, if you in algebra, if you needed to multiply out x plus 1 cubed, then you might have written it out 3 times, since that's a definition of cubing something. And then you'd FOIL this and you would get x squared plus 2x plus 1. And then now you'd have to multiply that times x plus 1. And then if you do a fourth power, then it takes even longer. So we're going to learn a formula for doing this. And it certainly makes it much shorter to use this formula. So to kind of look at where we're starting here. So, and we could write even a plus b to the 0. And that would, of course, equal 1 because anything to the 0 power is 1. So we have a plus b to the 0 is 1. A plus b to the first power, of course, is a plus b. You certainly would have seen this formula in algebra classes. A plus b squared is a squared plus 2ab plus b squared, and so on and so on. We don't need to read through all this, but let's notice a couple of patterns here. The first is whatever the exponent is, there is one more term in the expansion than the exponent. So when the exponent is 1, we have 2 terms. When the exponent is 2, we have 3 terms, and so on. So we always have one more exponent than, or one more term than what the exponent is. The other thing to notice is that we'll go down here to the 5th. So the a exponent decreases as we move along. So 5, 4, 3, 2, 1, 0, a to the 0. The b term, or the second term in the binomial, will go up. So here we have b to the 0, b to the first, b to the second, b to the third, b to the fourth, b to the 5th. So that will always be a pattern. So both of those things will be patterns. And then also, the last thing here, the sum of the exponents of a and b in each term is n. So the n here, or let's see, we can go up here since we marked that one up. The n here is 4. This is a to the 4th, b to the 0. So 4 plus 0 is 4. A to the 3rd, b to the 1st. So 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. And then 0 plus 4 is 4. So the exponents on the 2 terms that are here will always add up to whatever n is. So there's just a few things to kind of notice and pay attention to as we're going through these. Now, the next thing, you may have also seen this. I feel like I saw this when I was in high school algebra class, Pascal's triangle. And so this is just a way to remember the coefficients. And we'll go back up and look at the top in a minute after we do this. But we always start off with a 1, 1, 1 in a triangle like that. And then as we expand this triangle down, we always put a 1 on the ends. And then this term in the middle will be the sum of these two. So we have a 2 there. 1s go on the ends. And notice the number of terms is going up. So we have 1 number, 2 numbers, 3 numbers. Now we'll have 4 numbers. And the way to get these 2 in the middle is we're going to add those 2. 1 plus 2 is 3. 2 plus 1 is 3. And then doing it again, 1's on the ends. Now we're going to have 5 terms. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And if we want to do another one, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1 on the end. Okay, so this corresponds to a plus b to the 0, or whatever it is, a and b, or whatever we have. This one would be a plus b to the first, and so the ones here correspond to the coefficients there. This one corresponds to a plus b squared, and we could go up. We won't go up quite yet. In reference what we looked at earlier, but a plus b squared, if you multiply that out, you get a squared plus 2ab plus b squared. And so the coefficients 1, 2, 1 correspond to this row. And same thing here, a plus b cubed would be a cubed plus 3a squared b plus 3ab squared plus b cubed. And you can see, if you go up to the top, and if you have this printed out, you can easily see this. But the fourth line, 1, 4, 6, 4, 1, looking at the coefficients, and then 1, 4, 6, 4, 1. So this is a way to get the coefficients, and at least for the lower numbers, obviously, you're not going to go up to the 100th power using this triangle, but for the first, 5 or 6 or 7, you can work out this triangle pretty easily, and that will help with this expansion. So that's one tool that we might use a little bit. So let's look at this example. And so we are on the 5th power. So you can always find the row, because the first number is always a 1, first coefficient is always a 1, but this will be the 6th row in the triangle that we just did. And so you can always find the row, because the first coefficient will always be in. And so we're looking at this. This is the row that we need. So 1, 5, 10, 10, 1, 5, 10, 10, 5, 1. So that is our row from Pascal's triangle. All right. So if we expand this, so we're going to let a equal 2 and b equal 3x. And then, of course, n is 5. So this will be, and we could go up to up here and kind of use this as a pattern. So a to the 5th, 5a to the 4th, b, so on. And we'll see. So this is not something you need to memorize. We're kind of giving it to you here, but I'll explain a little bit more of the mechanics as we go along. But this is a fifth power, so let's just write this part again. So remember, the exponents on the a go down, the exponents on the b go up, and then these are telling us the coefficients. So 10a cubed b squared, and then 10a squared b cubed, and then 5a to the first, b to the 4th, and then b to the 4th. And so that is now all you have to do is plug in what a is and what b is. So we have 2 to the 5th, we have 5 times 2 to the 4th times b. All right, actually we should write 3x. B is 3x, and then 10 times 2 to the 3rd, and then 3x squared, and then 10 2 squared, and then 3x cubed, and then 5 times 2 times 3x to the 4th, and then 3x. That should be the 5th to the 5th. All right. And so now we just simplify these terms. So 2 to the 5th is going to be 32. 5 times 16 times 3. So that would be 240 x 10 times 8 times 9. 10 times 8 times 9 is 720 x squared. 10 times 4 times 27. 10 times 4 times 27 is 1080, and that will be x cubed. 5 times 2 times 3, this fourth should be on the outside. 5 times 2 times 3 to the fourth, and that would be 810 x to the fourth, and then 3 to the fifth is 243 x to the fifth. And that is the expanded version of that binomial to the fifth. So this can be a little bit tedious. If this n is not too large, then use Pascal's triangle. You can easily get to there if you know how to do it. It only takes a few seconds to get to that row. Those are the coefficients. The a exponents go down term by term, and then the b exponents go up term by term. And then it's just a matter of plugging in what a is and what b is, and simplifying from there. Combining, well, you're not combining any like terms, but multiplying those out. So, all right, so we'll stop here and pick it up on the next one.